folks, this is Murphy here doing a course introduction video for AP Statistics. I kind of wanted to talk about some of what the foundations of the course are so that you can kind of know what to expect moving forward. I want to define some vocab, and then we'll actually start with section 1.1, hopefully before the end of this video. So in terms of what stats is, as a noun, it could be described in two different ways, or there could be two different ways to use the word statistics. One is the discipline of statistics, which is what this course is named after, and it is the study of how to collect, organize, analyze, and interpret numerical info from data. So you may have noticed that the word compute or calculate is not in there, and that's because, unlike what you would probably expect from most math classes, we're not going to be solving for variables the whole time. In fact, we're going to go well beyond that into the thing that math is actually useful for. Like, how practical is it to solve for some unknown in real life as opposed to actually apply mathematical knowledge in some context that allows you to do things? So stats, the discipline, for example, is used in pretty much every hard science, like every STEM field sort of thing. Every soft science, like sociology and psychology, it's used in marketing and finances. It's used all over the place, and you're going to come to understand why that is by the end of this course, certainly. You may also recognize my disclaimer on the bottom that notes that all the formulas are going to be on a formula sheet I provide to you on the first day that you need to not lose. And anyway, our calculator is going to be able to handle most of the computations for us. That's the part that a computer could do. We need to be able to handle the stuff that computers can't do, such as the things described in this definition of statistics. Another way that you may have heard the word statistic is as some figure, a particular calculation made from data, and data are values within a context. So, for example, if I were to take the average age of everyone in our room, or any room really, in our room in particular, it's probably like 16 point something years. That's 16 point something would be a statistic. So these four things that describe AP Stats, these are not things that I made up. This is something that's in the AP course curriculum as things that we need to master before the end of this course. So one is exploring data, which we would define as describing patterns and departures from patterns. So a departure from data would be, for example, if I were to look at the average, like I said, the average age of people in our classroom, I would certainly be a departure from that age because I'm an adult and you are not. So if we were to plot our data on some graph that would be best suited to the data, I'd be somewhere else from it. Another thing is making sure that the data that we get is actually good, which is to say it's actually indicative of some population. It doesn't contain any biases. This is sampling and experimentation, which also involves planning and conducting a study. Anticipating patterns is like, all right, so once we've got some good data, some indicative data, once we've plotted the data, we can actually use it to make predictions about the future or about something unknown. This consists of exploring random phenomena using probability and simulation. Probability is a big part of this class too. And then last but not least is one of the biggest of big deals in stats, and it is inference. So inference is estimating population parameters and testing hypotheses. So for example, in our classroom, the average age might be 16 point something, but if I wanted to talk about all high school classrooms, I would use statistical inference to see the extent to which I can generalize that information, and it's a really powerful tool. We'll talk about why in the future. So in terms of bad stats, I'm going to present this to you, and I'm going to ask you to take a moment to read this scenario. When I take an obvious pause in my monologue here, I want you to pause the video, and then consider why the way that this was conducted is so bad, because it is. Also consider what you would do if you were the not-so-terrible analyst, and don't worry about using vocab in this case, because you don't know any vocab, but use your natural intuition to figure out why the wrong things are wrong here, and then see what you can do to fix it. So at this point, I'm going to take a moment to pause and allow you to pause the video and think things through yourself, and then hit play when you're ready to go again. That was probably long enough, right? So let's see, a terrible analyst. Hopefully, and the bad things are not limited to what I've written here. I do this every year, and people usually pile on with even more things, but I think the most prominent things are only varsity lacrosse players were asked. Look at who this is supposed to represent. Wants to determine how its athletes feel about practicing 2 hours a day, so he conducts a survey. We're talking about all athletes from this school. How indicative of the population of all athletes is varsity lacrosse players going to be? So varsity lacrosse players, first of all, they're varsity, so maybe that has something to do with their overall opinion of high school sports and practice hours, and also they're lacrosse players. So there's other variables such as how do they feel about their coach? Is their coach very good? How does that coach run a practice? What does a lacrosse practice actually look like? And you can imagine that they might have a different feeling than, say, like bowling players at whatever school has a bowling team. Also, only 7 people were asked, which it's tough to generalize from a sample size of 7. Um, we're going to take a big portion of classes in the future to talk about what is a sufficient sample size to try to generalize. I'll tell you right now, it's pretty much never going to be 7. Um, Also, he asks the first people to walk into the locker room. That was the way in which he conducted his study. You can imagine that the first 7 people to go into the locker room might have something that sets them apart from the others. Maybe they just want to get the heck out of there sooner than everyone else, so they'd have a negative feeling about having longer practices. Or maybe they're the ones who are in better shape and can actually drag their butts to the locker room sooner. So maybe they're under-challenged by 1-hour practices and they prefer 2-hour practices. It's all a possibility. We don't know which way it goes. And that's part of the reason why we would have to amend our study to be better. Also, we infer too much from the sample because, like I said, this is not at all indicative of a broader group. So maybe it's a bad idea to say that just because this group feels this way, then everybody feels this way. How could we fix this? Well, we could expand to random samples of all athletes. That would help. And hopefully the randomness of our sample, in the way it's conducted, would maybe kind of make up for the diversity of our population of all athletes. Think of it that way. We erased that 7 was too small, so jack up that sample size. And then in terms of inference, well, there's mathy things that you'll know how to do in the future that'll allow us to potentially generalize with some degree of confidence. So, pause and go back if you have to, but I'm going to throw some vocab at you, and I've already defined it in this left column. And just to make sure that this vocab is actually sticking, I'm going to ask you to consider what each of these words would be in the context of the previous example. So population's a word I threw around a bunch. It is the entire set of focus for statistical study. And it is, from the last example, not the entire school. No, but it is all athletes from this school. From this school. Not all high school athletes either, but in this school in particular. The sample is the portion of the population selected to represent it. It is the group of the 7 selected lacrosse players. The individuals are each of those players. Once you put all the individuals together in a set, you get the sample. And a census is when the sample actually matches the population, when you literally ask everyone who you are trying to represent. Was this one? No. Not all the athletes in high school were asked, not even most of them, and the ones who were asked weren't asked well in a well-conducted study. A variable. Don't think like x, like lowercase x, or like y, or like the type of things you usually think of when you think of a variable in math. Think of it more in a general sense, like the root word, vary. It is the characteristic of an individual to be studied or observed, and really the root word is vary because we look at how this characteristics would vary from individual to individual. So the example from the last page, the thing of study, the variable, would be practice preference. Yes or no for 2 hours or 1 hour. So every variable in this course can be put into one of 2 groups. It could either be a categorical / qualitative variable or a quantitative variable. Basically, one is a number and one isn't. That's the less wordy definition of these things. But if I ask you what kind the last one was, what kind this is, practice preference, hopefully you conclude that it's a categorical variable. Yes, I know it's kind of like 2 hour versus 1 hour, but the way in which it was phrased is that people would be answering with yes or no's. Yeses, no's are not numbers. We're not counting binary here. So it's categorical. Responses were non-numeric. So there are ways that I can kind of represent a set of responses as either categorical or quantitative. Like, for instance, if I'm talking about people's grades, they could either categorize themselves as freshman, sophomore, junior, senior, and that's obviously categorical, or they could say 9th grade, 10th grade, 11th grade, 12th grade. That doesn't really have too much of an impact. I guess it changes one type of variable to the other, but the only real impact that would have is the way that we represent the data. You can imagine how a graph of categorical data might look different than quantitative data. Speaking of which, section 1.1 is going to be analyzing categorical data. I'm going to break this up into 2 sections, 1.1a and 1.1b, and we're going to cover the first objective in this video, identifying what makes some graphs of categorical data deceptive. This is one of my favorite things to talk about. Again, I'm going to ask you to take this video and pause it for a moment maybe and try to answer the question when comparing these 2 graphs. It should be obvious, but also ask yourself, like, why is the worst graph worse? What is the graph meant to accomplish that the first one fails to do and the good graph is actually good at? So pause the video, take like I don't know, take as much time as you need to come up with the answer to the question, and then hit play when you're ready to go. I'm going to assume if you're ready now, then you've hit play. So hopefully you concluded that the right one is the better one, and the left one is bad. In terms of why the left one is so bad, well, what it does is it does a poor job of representing trends in the data. The right one does a pretty good job. It shows a nonlinear, at first slowly, then more quickly, then slowly again increase. Well, we could also see the variables presented well. It's a miles per gallon over time graph. We can see the rate of change between the quantities, whereas on the left one, it's not so great. For example, there's no x and y axes for scale. It's just one side of the road and then the other. The space between the values is disproportionate. So for instance, even though we're talking about increasing by a single year at a time, the gap between the years differs. And then also it's decreasing from top to bottom, which is not how we know the y-axis to work. So it's a little confusing. It doesn't really show, it doesn't really show what we need it to show. And my guess would be that, if you can see where this is, it was in the New York Times. This is probably made by someone who doesn't have a background in stats or math. They probably have a background in marketing, which is why they added a context to make it look pretty, but in doing so, they kind of defeated the purpose. The right one is the way to go. Some more bad graphs, which is a really fun thing for me to look at, I think. The one on the left. Take a second to analyze each of these things, recognize what it's saying here, recognize what the people mean, and recognize how absurd it is that this graph seems to be depicting that on average, if you stack 2.5 Filipinos on top of each other, you get someone from the Netherlands. That's not exactly how it works, and you know. If you were to ask yourself why this graph is so bad, hopefully you noticed that the average height in males is the y-axis, and it's truncated. It starts at 1.5 meters. Sorry, that's meters, not males. 1.5 meters, which, like, okay, it's fine to truncate graphs, and I see what they've done is make, like, a cute little bar graph, but they've turned the bars into people instead. But why do it like this? Here's a better way to do it. Here's the non-truncated version, but if they were to go untruncated at 1.5, maybe they should kind of reflect that they'd only be looking at the men's torsos, or upper bodies in particular, and then not have a silly thing where the feet start at the truncated value. They've done a bad job here. The thing on the right, yes, this is something that I actually took a picture of when I was at a sales pitch at a Marriott timeshare. Those are always interesting. The data here, this was kind of thrown at me and my wife as an incentive to say, like, look, prices are rising rapidly as time goes on, so the best time to get in on this and sign up is now. That way you pay less than if you were to sign up in the future. Like, okay, fine. But look at how they laid things out, and try to look at how this is wrong too. We should notice with a little more scrutiny is that the times, or the dates, they aren't consistent from one thing to another. Additionally, the same thing with the prices on the y-axis. So even though it does depict correctly, even though correctly depicts growth, that the prices get more expensive as time goes on, this really seems to be showing that growth is linear, which we know is not the case. I took this data, I let the first data point be times 0, and then counted the number of months since that time. And then I replotted the data in Excel. So when I did this, I made a scatter plot, and the scatter plot did depict growth, but not linear growth, and certainly not a growth with a slope this steep. So even though, and this is assuming all the figures here are correct, let's assume that Marriott's not lying to us, right? It's still the case that the way it's depicted is leading one to believe a thing that's not true, and that's problematic. That's not good graph making. I'm gonna throw these 6 at you. Some more fun. I really like bad stats. It's really fun to consider. So take a second to think through why each of these is bad, perhaps, and also maybe the motivation why things are being depicted the way they are, especially if it's not totally indicative of the truth. So again, take a little bit to pause and check out each of these graphs and see what's going on with them. All right, so at this point, I hope you hit play, because I'm going to keep going anyway. The first one, well, Americans who have tried marijuana is the context. 51%, 43%, 34%. That doesn't add up to 100. Pie graphs are supposed to add up to 100. Why doesn't this one add up to 100? Well, again, let's assume that the data points are actually correct, and if you asked somebody today, I don't know when this poll was taken, but today, in air quotes, then 51% of those people, on average, would say that they have tried marijuana. Okay, fine. Well, what if I asked someone in 1997? What if I asked my cousin Robbie, have you smoked pot in the year 1997? He'd be like, oh, totally, dude. And then I ask him again today, hey, Robbie, have you smoked pot ever? He's like, well yeah, definitely. People who fall into the 1997 yes category are going to fall into the yes category every year afterwards. So as it turns out, these categories are not mutually exclusive. People can fall into more than one of these colors, which makes a pie chart not the ideal chart for this data. So problematically, the percentages add up to more than 100, and the categories are not exclusive. Try to think in your head what might be a better graph for this data, because that's what we'll get to eventually. This one, Maduro versus, I don't know this guy's name, and it's cut off. Well, that's actually part of the problem. The heights of the bars are misleading, certainly. They make it's nearly a 50-50 split, but they make the second one look so small. And it's a problem that this graph is presented so poorly, with what is such a minor lead looking like a gigantic lead, mainly because this organization is owned by Maduro. Yes, he owns this company. Who would have guessed then that he would try to pull sneaky on the viewers and try to make his popularity inflated? For this top right one, how concerned are you about the Zika virus? Again, I don't know the dates of these things. I just pulled them from the internet, but it should be very obvious what's going on here and why it's a problem. Yes, these are real things that made the news. Also, note that I have a couple different news companies, so keep your politics at the door, dude. We're gonna try to examine every news organization, every political issue, not as someone with particular thoughts about it, but as statists who can criticize, obviously, things that we disagree with, but as well as arguments that are made in our favor, because I don't know about you, but if I believe something, I'd want my arguments in favor of that thing to be refined. So if we talk politics, if we look like we're ripping up news stations here, it's all in the idea of being better statists. So think of it in that regard. Nothing personal against Channel 2 News here, but they did a bad job with this graph. I don't know how 13% became the biggest one. I don't know how 28% became 0% somehow. I'm going to guess that whereas the second graph was probably intentional, this one was probably an accident, maybe even a computer glitch. For the bottom left one, democracy since 1900. This channel is usually pretty good, but they did a bad job with this graph because, well, look how this is laid out. First of all, this is not a categorical data. A categorical variable, rather. I don't think, at least. That's part of the problem. I don't know how to quantify democracy, but they make it look like it's increasing. And even so, there's really not a y-axis for scale. So even though this channel, who I can't pronounce, usually does a pretty good job of citing their stuff, this graph in the moment was really ineffective, I think. The second one here, the second on the bottom, DirecTV stomps the competition. So look at them. Look at how much bigger this blue rectangle is than this red one and then this yellow one. Well, the heights are not proportional. For instance, the gap between 81 and 95 is a lot bigger visually than the gap between 81 and 56, and we know that that's not true numerically, so that's an issue. And also the lengths of the boxes exaggerate the difference. So as opposed to actual bar graphs, this data could be represented in bar graphs. They've decided to add width too, and the width of DirecTV kind of makes you maybe subconsciously compare the areas of these bars instead of their heights by adding that other dimension to it, rather than having, this wasn't a great graph, but what they did good is they had the bars be very comparable in that they're the same width. That's about the only good thing you can say about this one. But anyway, yeah. Again, think about why they probably did this. Maybe subconsciously they wanted people to think that DirecTV was so much better than the other networks, and they decided to exaggerate that difference by adding some width to the bars as well. So Fox News, the cost of gas, national average. Again, after we've come this far, I'm sure you could see, with even a little bit of scrutiny, what they've done not too well here. The truncated y-axis really exaggerates the difference. Notice it starts at 250. And then also there's inconsistent time intervals. Last year, last week, current. That's not great. This is a difference of 1 week. To go from first to last is a difference of 52 weeks, but roughly 52 weeks, but they all looks the same. Not great, not great. So, this is the conclusion of this video. I'll pick up with another one soon.